Assalamualaikum and hello everyone. Today I would like to discuss with you guys about chapter 2 with this small concept. The topic outline that had been given to me is atomic mass unit AMU, yang atau relative molecular mass dan molar mass. In this chapter, learning objective, you can get understand concept of atomic mass AMU, and you can understand relative atomic mass RAM and calculate relative molecular mass RMM. Okay, you can understand relate mole and mass, and you can relate mole and Avogadro's number. Understand concept of molar mass, and you can calculate empirical formula and identify molecular formula of compound. First of all, I would like to begin with the atomic mass unit, or what we call AMU. Atomic mass unit because the masses of atomic and subatomic practice are so small and convenient unit to use is the atomic mass AMU. 1. AMU equals 1.6605 times 10 to power of 24 gram. And the masses of the proton and neutron are approximately 1 AMU, and the masses of the electron is about 0.0005 AMU. I choose copper for example atomic mass. I choose copper 63 and 65. Okay, you can use the atomic mass formula is fractional abundance or isotope time to mass of isotope. Okay, for solution of the atomic mass is bracket 0.16917 time to 2.9368 AMU plus 0.13083 time 864.9278 AMU. Okay, you can get the 90.5525 and you can change to 93.55 AMU. Okay, this is for find the copper's atomic mass. Okay, next we go to the relative atomic mass, or what we call is RAM. Okay, the relative atomic mass is average mass of one molecule, often when compared with 1/12 of the mass of an atomic of carbon 12, or compare with one normal hydrogen atom. Okay, you can use the formula is mass of one molecule of the elements, or compare divide by 1/12 time mass of one carbon 12 atom. For example, relative atomic mass, I choose chlorine. Okay, you can use the formula relative atomic mass to get the answer. 34.969 times 75.8 plus 66.966 times 24.2 divide the 100. You can get the 35.45. Okay. Let us proceed to our next discussion, which is the relative molecular mass, RMM. RMM is the average mass one of molecule of a substance when compared with 1/12 of the mass of an atom of carbon 12 or compare with one normal hydrogen atom. Okay, you can use the formula for RMM is mass of one molecule of the element or compound divided by 1/12 times mass of one carbon 12 atom. For example, to calculate the reactive molecular mass, I choose sodium chloride. This NaCl, 1 sodium plus 1 chloride, bracket 1 times 23 plus bracket 1 times 35.5, can get 55.5. Okay, the second example is zinc chloride. Okay, you can 1 zinc chloride plus 2 chloride. Okay, you can calculate bracket 1 times 35 and 65 plus 2 times 25.5, you can get 139. Last but not least, we are going to discuss about the molar mass. Okay, the molar mass of the mole substance is called single mole. Okay, the unit molar mass is gram per mole. Okay, the molar mass of substance numerically for relative atomic mass, relative molecular mass, or formula mass. Okay, the formula you can use to calculate the molar mass is formula mass bracket number of atom of one elements in chemical formula time atomic mass of one element plus bracket number of atomic of two elements in chemical formula time atomic mass of two elements. For example, to calculate the molar mass, I choose 3 elements. Okay, first element is H2O. Okay, you can use the formula mass. 2 bracket 1.0 plus 60.0 divided to 80.0 gram per mole. Okay, the second is I choose NH42 CrO4. Okay, you can use the formula 2 bracket 40.0 plus 8 bracket 1.0 plus 52.0 plus 4 bracket 60.0 divided to 152 gram per mole. Okay, the third element in molar mass is NO32. Okay, you can use formula mass 137.3 plus 2 bracket 40.0 plus 6 bracket 60.0 divided to 261.3 gram per mole.
Assalamualaikum and hi. My name is Natalia Ain binti Anjasmi. So today I will present to you about a subtopic which is mole concept. So what is mole? Mole is defined as that amount of substance which has mass equal to gram atomic mass if the substance is atomic or gram or molecular mass. Mole equal number of particles equal to the number atoms in 12 gram of carbon 12. So we have here one atom of carbon 12 weighs exactly 12 AMU, which is atomic mass units. And we also have here 1 mole of carbon 12 weighs exactly 12 gram. So atomic mass units same as the gram. Next is the number of particles in 1 mole is called Avogadro's number. So Avogadro's number is 6.023 times 10 the power of 23. So we have here 1 mole of carbon atom weighs 12.01 gram and has 6.023 times 10 the power of 23, which is the Avogadro's number. For example, so here we have 1 mole of copper contains 6.023 times 10 the power of 23 of copper atoms. So the first one is atoms. So the second one is 1 mole of water H2O contains 6.023 times 10 the power of 23 of H2O molecules. So the second one is molecules. And the last one is 1 mole of magnesium chloride crystal contains 6.023 times 10 power of 23 of magnesium chloride formula units. So the last one is cation plus anion. So as you can see here, so this is the formula. Mole substance equal to mass in gram of substance divided by molar mass of substance units. So the units is G per mole. So the second one is number of elementary units equal mole multiplied by Avogadro's number. So the number of elementary units, we have 3 here. So atoms, molecules, and formula units. So this is the important relationship, which is the ethanol. So this is the formula of ethanol, C2H5OH. So as you can see here, that is the molecular weight, which is 46.07. This ethanol is a molecule. In this one molecule contains 2 carbon atoms, 1 oxygen atoms, and 6 hydrogen atoms. And same goes to the mole. 1 mole contains 2 moles of carbon atoms, 1 mole of oxygen atoms, and 6 moles hydrogen atoms. So this is the example of 2.3. So the question is, how many atoms are in 0.551 gram of potassium? So that is the formula, which is number of particles equals to number of moles multiplied by number of Avogadro's number, which is 6.22 times 10 the power of 23. So the first step is 1 mole potassium equal to 39.10 gram potassium. 1 mole potassium equals to 6.022 times 10 the power of 23 atoms, which is the Avogadro's number. So 0.551 gram potassium is the mass of the potassium, and we'll multiply by 1 mole potassium divided by 39.01 gram potassium multiplied by 6.022 times 10 the power of 23 atoms potassium divided by 1 mole potassium, and you will get 8.49 multiply times the power of 21 atoms potassium. So next is Avogadro's number. Avogadro's number is a proportion that relates molar mass on an atomic scale to physical mass on a human scale. Avogadro's number is defined as the number of elementary particles, which is molecules, atoms, compounds, and so on per mole of a substance. It is equal to 6.22 times 10 to the power of 23 per mole and is expressed as the symbol Na. So the number of particles equals number of moles multiplied by the Avogadro's number, same as the previous questions. So this is the relationship. So this is the example of 2.6, which is calculate the number of atoms in 2.45 mole of copper. So given is 2.45 mole of copper, so we have to find the atoms of copper. So the relationship is between Avogadro's number, which is 6.022 times 10 to the power of 23 atoms, will divide by 1 mole, because 1 mole is equal to 6.022 multiplied by 10.23 atoms. So the first step is we have the number of particle, which is 2.45 mole copper, multiplied by the Avogadro's number, which is 6.022 times 10 to the power of 23 atoms, divide by 1 mole. So we will get 1.848 times 10 to the power of 24 atoms copper. Because the atoms are small, so the large number of atoms makes sense. So the last one is about mole and molar volume of gas. So this is another measurement that can be used to quantify the substances in chemical reaction is a volume. So when there's reactant in gas, the relationship between mole and volume will be used. So the volume of gas depends on the pressure and temperature. So right now we have two, which is at standard temperature and pressure, or we call as STP. So the value is 22.4 liter, and the second one is at room temperature and pressure, or we call as RTP. So the values is 24 liter. So this is the relationship of mole and volume. So if the element is gaseous, relationship between moles volume and molar volume can be summarized as follows. So this is the formula. The volume equals to number of mole multiplied by molar volume. For example, so the question is calculate the volume occupied by 1.25 moles N2 gas at STP. Given that 1 mole of gas occupies 22.4 liter at STP. So the solution is when in STP, the volume of 1 mole of N2 gases equals to 22.4 liter. So the volume of 1.25 moles N2 gases equals to the number of mole multiplied by molar volume, which is 6.25 moles multiplied by 22.4 L per moles, and the answer is 28 liter. So the next example is calculate the number of moles of ammonia gas in H3, which is the ammonia gas formula, in a volume of 80 L of gas measured as STP. So the solution is we use the same formula, which is the volume of gas equals to the number of moles multiplied by 22.4 1 liter per mole. So number of moles, so we don't have the number of moles, so the volume of moles, which is 80, will divide by the STP values, which is 22.41 liter, and we will get 3.569 liter. So that's it from me. Thank you.
Assalamualaikum. My name is Nur Adini Balkis, and I want to continue this topic about empirical formula and molecular formula. Definition of empirical formula is a formula that gives a simple whole number ratio of the different atoms in a compound. For example, H2O2 is hydrogen peroxide. H2 is empirical formula for hydrogen peroxide. C6H12O6 is glucose. And what is empirical formula? Next, how to finding an empirical formula. First, convert the percentage grams. Assume you start with 100 grams of compound. Skip if already in grams. Second, convert grams to moles, and you can use smaller mass of each element. Divide all by smallest number of moles. If result is within 0.1 of whole number, round to whole number. And last, multiply all mole ratio by a number to make all whole numbers. For example, if ratio something 0.5, multiply all by 2. If ratio something 0.33 or something 0.67, multiply all by 3. If ratio 0.25 or 0.75, multiply all by 4. And then you can skip if already whole number. For example 2.11, laboratory analysis of aspirin determine the following mass percent composition as follows: carbon 60%, hydrogen 40-48%, and oxygen 35.53%. Calculate the empirical formula of aspirin. Solution: in 100 gram of aspirin, there are 60 gram carbon, 40-48 gram hydrogen, 35.53 gram oxygen. The conceptual plan is gram carbon to molecule carbon to molecule ratio, whole number ratio. Empirical formula: gram hydrogen to mole hydrogen, to mole ratio, whole number ratio. To empirical formula: gram oxygen to mole ratio, to whole number ratio, and empirical formula. For example, given the molar mass, 1 mole carbon 12.01 gram, 1 mole hydrogen 1.008 gram, 1 mole oxygen 16.00 gram. Calculate the moles of each element. 60.00 gram carbon divide to 1 mole carbon multiply 12.01 gram carbon equal 4.996 mole carbon. Then 4.48 gram hydrogen divide to 1 mole hydrogen multiply 1.008 gram hydrogen equal 4.44 mole hydrogen. And last, 35.53 gram oxygen divide to 1 mole oxygen multiply 16 gram oxygen equal 2.22 mole oxygen. The mole ratio of carbon, hydrogen, oxygen equal 4.996, 4.44 and 2.220. Divide the mole ratio by the smallest number of mole in the above mole ratio to get the whole number mole ratio. Whole number mole ratio carbon, hydrogen, oxygen 4.996 multiply 2.220, 4.44 multiply 2.220, and 2.220 multiply 2.220 equal 2.25, 2 and 1. Choose a small number to multiply the mole ratio in order to get the whole number mole ratio. Multiply by 4. Carbon, hydrogen, oxygen equal 2.25 divide to 4, 2 divide 4 and 1 divide 4, and the answer 9, 8 and 4. The empirical formula of carbon 9, hydrogen 8 and oxygen 4. Once you have learned how to convert one unit to another according to the conceptual plan, you can evaluate the empirical formula in a format table. This is how to find empirical and molecular formula. First, make a table, element A, B and C, percentage composition by mass in gram, relative atomic mass, number of moles, mole ratio, simplest ratio, whole number. This is how to get empirical formula. Element carbon, hydrogen and oxygen, percentage composition by mass in gram, carbon 60, hydrogen 40.48, oxygen 35.53, relative atomic mass, carbon 12.01, hydrogen 1.008, oxygen 16.00. Number of moles, carbon 49.96, hydrogen 40.44, oxygen 2.220. Mole ratio, carbon 49.96 multiply 2.220, hydrogen 4.44 multiply 2.220, and oxygen 2.220 multiply 2.220. Simplest ratio, divide 4. Carbon 9, hydrogen 8 and oxygen 4. Then what is molecular formula? The molecular formula is a multiple of the empirical formula. For example, hydrogen oxygen is empirical formula. H2O2 is a twice of hydrogen oxygen. Hydrogen oxygen must divide with X and X equal 2. For carbon 6, hydrogen 12 and oxygen 6, the empirical formula is carbon, hydrogen 2 and oxygen and X equals 6. To determine the molecular formula, you need to know the empirical formula and the molar mass of the compound. Molecular formula weight N divide empirical formula weight. N is the number of empirical units in the molecule. Example 2.12, find the molecular formula of butanedione. Empirical formula, carbon 2, hydrogen 3 and oxygen. Molar mass 86.03 gram per mole. Find molecular formula. Conceptual plan and relationships. Molecular formula equal empirical formula, divide N. And N equal molar mass, multiply empirical formula, divide molar mass. Solution, molar mass empirical formula, molar mass divide empirical formula, 2 divide 12.01 gram per mole plus 3 divide 1.008 gram mole plus 1 divide 16 gram mole equal 43.04 gram per mole. N equal 86.09 gram per mole multiply 43.04 gram per mole equal to molecular formula equals carbon 2, hydrogen 3 and oxygen divide 2 equals carbon 4, hydrogen 6 and oxygen 2. Check the molar mass of the calculate formula is in agreement with the given molar mass. And last, for example 2.13, benzopyrene has a molar mass of 252 gram and an empirical formula of carbon 5, hydrogen 3. What is its molecular formula? Carbon 12.01 and hydrogen 1.01. Carbon 5 equal 5 divide 12.01 gram equals 60.05 gram. Hydrogen 3 equal 3 divide 1.01 gram equal 3.03 gram. And equal carbon 5, hydrogen 3, 63.08 gram. And N equal 252 gram per mole multiply 6308.08 gram per mole equal 4. Molecular formula equal of carbon 5, hydrogen 3 must divide 4 equals carbon 20 and hydrogen 12. That's all from me. Thank you.